So, in this challenge problem, we are given a polynomial and we are given a real zero that the polynomial has, and we're asked to find all the other zeros of the polynomial. Okay, so this problem is tough, not necessarily because it is hard to work out, but you really have to apply understanding of all of the sections up until now to understand what this problem is asking, how we would go about solving it, and then actually applying the skills to solving the polynomial. So, okay. Let's look at the main overarching idea of what we have to do. We are asked to find the remaining real zeros. Even ignore the idea of remaining real zeros. What would I need to do to find the real zeros of a polynomial? Well, I would need to fully factor the polynomial to get it in terms of a series of multiplication of factors, set each of those factors equal to 0, and solve. So the end goal, or at least the step right before we solve the problem, would be completely factorizing this polynomial. Okay, so that's like a slightly easier goal to reach. How do I factor this polynomial? Okay, well, we have a cubic equation, and we don't know how to factor those. We only know how to factor quadratics. However, we're given one real zero, and hopefully you might get the context that in a worksheet about long division and synthetic division, we might want to try dividing out our zero. So let's briefly think about, what does this term c equal 1 mean? It means that c equals 1 is a 0, and we know that zeros come from factors. So I know that in the final factorization of this polynomial, there is some term that looks like x minus c. And I want to take this term and divide it by our polynomial. And what division technique uses a 0 as part of its setup? Well, synthetic division. So what I'm going to do is I'm going to use x minus c to set up synthetic division for this polynomial. So let's look at how that will work. So let's draw our table. And now let's put this 0 of 1 on the left side of the table. Now let's go through, write out our coefficients. So we have 1, -6, 11, -6. And now let's complete the division and see what we get back. So I'll bring down the 1. 1 times 1 is 1. -6 plus +1 is -5. -5 times 1 is -5. -5 plus 11 is +6. And +6 times 1 is 6. And when I add this final column, I get a remainder of 0. And so let's briefly interpret the remaining polynomial. So this would become x squared minus 5x plus 6. Now, before I continue with this, let's write out our polynomial in that form of px times dx qx plus rx, just to see what situation we have, right? So we have that px, which is our original polynomial, is equal to the 0 times our resulting polynomial. Now, this is already... sorry, I forgot to mention one thing. The key ingredient here is the fact that our remainder is 0. Because our remainder is 0, there's nothing extra we have holding on to, and you can already see that this is starting to look like a factorization. The only thing we're missing is factorizing this. But we actually do know how to factor quadratics. So now we'll ask ourselves, what is the factorization of x squared minus 5x plus 6? Well, I need to find two numbers that add together to -5 and that multiply to 6. So that will probably look like -3 and -2. So I can write x minus 3, x minus 2, because -3 plus -2 is -5, but -3 times -2 is 6. And then we can extract from that zeros. So I can extract that x equals 3 and that x equals 2. And you'll notice if I put this back into my equation, we can see that we can fully factor out, not x squared. We can fully factor out the original polynomial into this form. And we found 2 zeros from these values, and we already know that this thing gives us x equals 1. And as you can see, we've fully factored our polynomial, and I need to scroll down, my face cam is blocking. But we fully factored the polynomial, and we have found all 3 zeros associated with it. And all we had to do was divide a linear term from a cubic to turn it into a quadratic, which is something that we can't factor. So keep that skill in mind, keep that idea of dividing off a linear to make a quadratic, dividing off a linear from a cubic to make a quadratic factorable, because it's going to be a very important skill that you can use in more difficult problems.